Breaking news. You don't want to forget. Something is pulling on the edge of our solar system. We cannot see it, we cannot photograph it, we do not know exactly where it is, and we are not even completely sure what it is. But distant objects at the edge of our solar system are moving in strange ways. Their orbits appear to be clustered, their paths seem to be influenced by something massive, something hidden in the darkness, and after decades of searching, astronomers may have finally found a possible clue, not through a brand new photograph, not through a spacecraft that traveled to the edge of the solar system, but inside data collected by two infrared satellites more than 20 years apart. Researchers searched through millions of objects. They eliminated almost everything. Millions became thousands, thousands became hundreds, hundreds became 13, and 13 became one. One faint object, one tiny movement, one candidate that may represent the first direct evidence of a mysterious planet that astronomers have been searching for since 2016, a world potentially several times more massive than Earth. A world so distant that the sun would appear almost meaningless in its sky, a world that could take thousands of years to complete a single orbit, and a world that may have been quietly influencing the outer solar system for billions of years. The strange part is not simply that this planet might exist, the strange part is that something appears to be influencing the motion of objects at the edge of our solar system, and we still cannot see the source. For most of human history, the solar system seemed relatively simple. There was the sun at the center, there were the planets moving around it, and beyond the outermost known planets, there was darkness. But as our telescopes became more powerful, that simple picture began to fall apart. Astronomers started discovering objects beyond Neptune. Some were small, some were hundreds of kilometers across, some were frozen remnants left over from the formation of the solar system, and some were following orbits so unusual that they forced scientists to rethink what they believed about the outer solar system. These objects are known as trans-Neptunian objects. They exist beyond Neptune's orbit in a region filled with ancient debris left over from the birth of our planetary system. Billions of years ago, the solar system was not the organized system we see today. The young sun was surrounded by enormous amounts of material: gas, dust, rock, ice, and countless smaller objects that would eventually become planets, moons, asteroids, and comets. As the major planets formed, their gravity began throwing smaller objects in every direction. Some were pushed closer to the sun, some were captured into stable orbits, some were flung completely out of the solar system, and some were sent into extremely distant paths. So astronomers expected the outer solar system to be chaotic. They expected strange objects. They expected unusual orbits, but there is a difference between individual objects behaving strangely and multiple objects appearing to behave as if something is influencing them. Imagine throwing dozens of boats into a massive ocean. You would expect the boats to drift in different directions. Some would move north, some south, some east, some west. Their paths would be affected by waves, currents, and random forces. But now imagine discovering that many of those boats were mysteriously pointing in similar directions, not exactly identical, but close enough to make you ask a question. What is creating the current? That is the problem astronomers began facing at the distant edge of our solar system. Several objects appear to have orbits that were strangely aligned. Their paths were not completely random. And when scientists began studying those patterns, one possibility started to emerge. Perhaps something massive was influencing them, something that could not be seen directly. In 2016, astronomers Mike Brown and Konstantin Batygin studied the strange behavior of several distant trans-Neptunian objects. Their calculations suggested that the clustering of these objects was unlikely to be a simple coincidence. Instead, their orbits could be explained by the gravitational influence of a massive unseen object, a planet sized object, a world potentially several times more massive than Earth, a planet traveling on an enormous orbit far beyond Neptune, and this hypothetical world was given a simple name, Planet 9. But the name itself is not the most important part of the story. The real mystery is much bigger. How could a planet this massive be hiding in our own solar system? Humanity has photographed galaxies billions of light years away. We have detected planets orbiting stars so distant that their light traveled for years before reaching our telescopes. We have observed black holes that cannot be seen directly. We have sent spacecraft beyond the region where the sun's solar wind dominates space. And yet, there may be a planet in our own cosmic neighborhood that we have completely missed. At first, that sounds impossible. If Planet 9 is several times more massive than Earth, why can't we simply point a telescope at it? The answer is distance. A planet does not produce light like a star, it mostly reflects light from its star. Earth is visible because sunlight reaches our planet, reflects from its surface and atmosphere, and then travels back towards space. But as a planet moves farther away from the sun, the sunlight reaching it becomes weaker. Then the small amount of light it reflects must travel all the way back to Earth. The light has already traveled an enormous distance to reach the planet, then it must make the journey again. By the time it arrives at our telescopes, the signal can be incredibly faint. A distant planet may not look like a world at all, it may look like almost nothing, just a faint point of light hidden among billions of stars. And then there is another problem. Astronomers do not know exactly where Planet 9 is. They can estimate where it might be. They can calculate the kind of orbit it may follow. They can estimate its possible mass and temperature. But the solar system is enormous. Searching for Planet 9 is not like searching for a car in a parking lot. It is more like searching for one moving object in an ocean that is larger than anything humanity has ever explored. And the object may be moving so slowly that it barely changes position from one year to the next. For years, astronomers searched. Wide field surveys examined enormous portions of the sky. The Zwicky Transient Facility searched for faint moving objects. The Dark Energy Survey examined huge regions of space. Other surveys also searched for a distant world that might match the predicted characteristics of Planet 9. But nothing definitive appeared. No confirmed planet, no obvious photograph, no clear answer. The gravitational evidence seemed to point towards something, but the object itself remained invisible. And this is where the search took an unexpected turn. Instead of asking only where is the planet, scientists began asking what kind of signal would the planet produce. Because even if Planet 9 is extremely cold, it would not necessarily be completely invisible. Every planet emits some infrared radiation. A distant world may be too faint to detect through reflected sunlight, but it could still produce heat. And infrared telescopes are designed to detect exactly that kind of radiation, so researchers began searching through old infrared data. The first important survey came from the infrared astronomical satellite known as IRAS. In 1983, IRAS conducted one of the first all-sky infrared surveys from space. Then, more than 2 decades later, Japan's Akari infrared satellite surveyed the sky again. The time gap between the two missions created a remarkable opportunity. A distant planet would move very slowly across the sky. From Earth, it might appear almost stationary, but over more than 20 years, even a tiny movement could become measurable. If scientists could find an infrared object in the first survey and then find the same object in the second survey, they might be able to detect its motion. And if that motion matched what Planet 9 was expected to do, they could have a serious candidate. But the search was enormous. The combined data contained approximately 2.4 million objects, stars, galaxies, asteroids, infrared sources, objects from within our solar system, objects located far beyond it, and distant objects from across the universe. Some were bright, some were faint, some were stationary, some were moving, and somewhere inside all of this data there might be one distant planet. The researchers needed a way to narrow the search. They were not looking for just any moving object. They were looking for something with a very specific combination of characteristics: the right brightness, the right estimated temperature, the right size, the right distance, and the right amount of movement across the sky over more than 2 decades. Most objects could be eliminated. Some were too close, some were too bright, some were too faint, some moved in the wrong way, some did not move at all. The search continued, 2 million objects, then fewer and fewer and fewer, until the enormous search had been reduced to 13 possible candidates. 13 out of approximately 2.4 million objects, but 13 was still too many. Each candidate had to be examined carefully. Researchers had to compare the old infrared observations with the newer ones. They had to determine whether the apparent movement was real. They had to test whether the object could match the expected properties of Planet 9. One candidate after another was eliminated. Some failed to match the expected movement. Others did not have the right characteristics. Some simply did not fit the predictions until only one remained. One. a single candidate buried in decades old infrared data. In the original IRS image, the object was incredibly faint. There was no dramatic photograph, no visible planet, no recognizable surface, no colorful atmosphere. Just a few pixels that appeared slightly warmer than the surrounding background. 7 pixels. That was essentially the signal. If you looked at the image without knowing what you were searching for, you would probably never guess that it could represent a planet. But then researchers compared it with the Kari observation taken more than 20 years later, and the candidate had moved. The movement was tiny, but at such an enormous distance, tiny movement is exactly what astronomers would expect. The object had shifted across the sky by a measurable amount, and according to the research, the movement was consistent with the possibility of a distant planetary object. This is where the story becomes extraordinary, because for the first time, scientists were not simply saying there might be a planet out there, they were saying we may have found something that behaves like the object we were looking for. Could this be Planet 9? If it is, then humanity may have already captured its first image, but that image would not look like the photographs of Jupiter or Saturn. It would not show clouds, storms, rings, or a visible surface. It would look like a faint signal hidden inside old data, a few pixels in one survey, a movement across the sky, and a second observation more than 20 years later. That is all. But sometimes in astronomy, that is enough to begin a revolution. However, there is a problem. A candidate is not a discovery. The object has not yet been tracked long enough to completely map its orbit, and some researchers have raised concerns about whether its orbital inclination perfectly matches what would be expected from Planet 9. In other words, the object is interesting. It is worth following up. It may eventually turn out to be extremely important, but scientists cannot yet officially say we have discovered Planet 9. And this uncertainty creates an even bigger mystery. Because if this object is Planet 9, astronomers may have found the hidden world they have been searching for, but if it is not Planet 9, then the original problem remains. Something still needs to explain the strange behavior of distant objects. And now we have to consider the possibility that the answer may be something completely different. One possibility is that there is no single Planet 9 at all. Instead, the distant objects could be part of a massive belt, a huge population of smaller bodies whose combined gravitational influence creates the orbital patterns we observe. Think about a flock of birds. There is no single bird commanding every movement. The overall pattern emerges from thousands of small interactions. One bird changes direction, the birds around it react, then more birds react, and suddenly a huge group appears to move as one. Some researchers have proposed that a similar process could occur in the outer solar system. A massive collection of distant objects could influence one another. No single planet would be necessary, but there is another possibility. Perhaps the solar system was disturbed by something that passed through it long ago. The sun was born in a crowded stellar environment. It was not always isolated. Other stars may have passed relatively close to the young solar system. Their gravity could have disturbed distant objects, it could have changed their orbits, it could have pushed some objects into new paths, and a single encounter billions of years ago could leave behind a gravitational pattern that still exists today. But then there is an even stranger possibility. What if the object is not a planet? What if it is a primordial black hole? Primordial black holes are hypothetical objects that may have formed during the earliest moments of the universe. Unlike black holes created by the collapse of massive stars, primordial black holes could theoretically exist across a wide range of masses. In theory, one could have a mass comparable to a planet while being incredibly small in physical size. It would not shine like a star, it would not reflect sunlight, it might be almost impossible to detect directly, but its gravity would still be there. And this is one of the most fascinating aspects of astronomy. Sometimes you do not discover an object by seeing the object, you discover it by watching what it does to everything around it. The planets themselves are evidence of gravity. The movement of stars reveals invisible masses. The motion of galaxies can reveal structures that cannot be directly observed. So, if something is pulling on objects at the edge of the solar system, the source does not necessarily have to be visible, it only has to be massive enough to leave a gravitational fingerprint. Still, Planet 9 remains the explanation that captures the imagination, because if it exists, it would be a real world, a planet, a place a distant member of our solar system that has remained hidden from humanity for billions of years. Imagine standing on its surface. The sun would be incredibly distant. It would no longer dominate the sky the way it does from Earth. The landscape could exist in extreme cold. The planet might spend thousands of years completing a single orbit. Entire human civilizations could rise and disappear without Planet 9 completing one journey around the sun. And during all of that time, its gravity could continue influencing objects far beyond Neptune. But the search is now entering a new era, because the next major step may come from the Vera the 100th Rubin Observatory. The observatory was designed to repeatedly survey enormous regions of the night sky. Its enormous camera can detect objects far dimmer than many previous surveys. And the most important feature is not simply its ability to take a photograph, it is the ability to photograph the same regions again and again. A faint object that is almost invisible in one image may reveal itself when compared with another. A tiny movement can become evidence. A point of light can become a world, and a world can become a discovery. The observatory could dramatically expand the number of known objects in our solar system. It could reveal distant worlds that have never been detected before. It could discover new orbital patterns. It could test whether the strange clustering that led to the Planet 9 hypothesis is real. And if Planet 9 is located in the region where the models predict, it may not be able to hide forever. The search that began with strange orbital behavior could finally end with a real image, a confirmed planet, a new member of the solar system. But the opposite result would be just as important. If the observatory finds no Planet 9, scientists will have to examine the alternatives more seriously. Maybe the strange orbits are caused by a distant belt. Maybe a star disturbed the solar system billions of years ago. Maybe an invisible object is still there. Maybe the candidate found in old infrared data is only one piece of a much larger puzzle, and maybe the outer solar system is not organized in the way we think it is, because the deeper astronomers look, the less complete our cosmic map becomes. For centuries, humanity believed the stars were fixed points in the sky. Then we discovered that they were suns. We believed the Milky Way was the entire universe. Then we discovered billions of other galaxies. We believed the solar system was relatively simple. Then we discovered distant icy worlds, strange objects, enormous regions of debris, and mysteries that still have no confirmed explanation. We once thought Pluto marked the outer frontier of the solar system. Then we discovered the Kuiper Belt. Beyond it, astronomers found even stranger objects. And farther out still, there may be a vast cloud of icy bodies surrounding the entire solar system. The Oort cloud, if it exists as predicted, could extend to distances so enormous that even our fastest spacecraft would require tens of thousands of years to cross it. Voyager spacecraft have already traveled beyond the heliosphere and into interstellar space, but compared with the possible size of the outer solar system, even that achievement represents only a tiny journey. That is the part that is difficult to comprehend. Humanity has sent spacecraft beyond the sun's protective bubble. We have detected planets orbiting other stars. We have photographed galaxies billions of light years away, and yet our own solar system may contain entire worlds that remain completely unknown to us. We have not explored the solar system, we have sampled it, we have visited a handful of planets and moons. We have sent robotic spacecraft through an incredibly small fraction of its total volume. The rest is darkness. So is Planet 9 real? Right now, the answer is still unknown. The infrared candidate is not enough to officially confirm a new planet. The orbital evidence is compelling enough to keep the search alive, but not yet strong enough to end the debate. The object found in old data could eventually be confirmed. It could disappear as a false lead. It could turn out to be something else entirely. And perhaps that uncertainty is what makes the mystery so fascinating. Because we are not waiting for a science fiction discovery, we are waiting for evidence, more observations, more movement, more data. And somewhere in the next images collected by the most powerful surveys ever designed to map the sky, the answer may already be on its way. Maybe astronomers will finally see a new planet. Maybe they will discover a vast population of distant worlds. Maybe they will find evidence of a cosmic encounter that happened billions of years ago. Maybe they will discover an object that does not fit any familiar category. Or maybe they will discover that the gravitational mystery was pointing towards something even stranger than Planet 9. For now, the evidence points toward a mystery. Distant objects are behaving in strange ways. A faint candidate has emerged from decades old infrared observations, and a new generation of telescopes is preparing to search the darkness with unprecedented power. The most important question is no longer simply, is Planet 9 out there? The deeper question is, what has been shaping the edge of our solar system all this time? Because whatever the answer is, one thing is becoming increasingly difficult to ignore. Something appears to be influencing the motion of distant worlds. We cannot see the source, we cannot yet prove exactly what it is, but the gravity is there, and somewhere beyond the known planets, in a region of darkness so vast that our spacecraft have barely entered it, something may be pulling on our solar system. And NASA, along with astronomers around the world, may finally be getting close enough to find out what. Thanks for watching. Please do like and subscribe. We will meet you in the upcoming video soon.